All right, in my last video, I probably didn't do a great job of explaining the purpose of it, and sometimes that's because I don't really know the purpose when I start on these. I just sort of have a hunch or an idea, and I kind of run with it. So so I got some feedback from heatinghelp.com forum, and actually a little bit of weird feedback from there's a Steam Facebook group that's not as polite as the Heating Help forum, and I got some various feedback there, and some suggestions, and thought I would make another video with some adjustments and some additional, maybe clearer commentary. We'll see. You can be the judge of that. So the purpose of that last video and this video, it turns out, was to show that carryover, and that is to say large amounts of water getting thrown up into the header and or main, that carryover is probably, I'm going to say it, is probably not usually or not ever caused by bad boiler piping. We see all kinds of crazy bad boiler piping on the Heating Help forums because that's why people come for help, and then we see all the mistakes that their installers made, and that's everything from no header at all. Here's my header. I've got what's called a drop header, so the steam supply comes up and goes down to the header, which then comes across here and then goes up here to send the steam up to the main. All right. So sometimes there's no header at all, where the supply runs straight directly up to the main. Sometimes we see it piped in copper. Sometimes we see it undersized. So this boiler requires 2 inches, a single 2-inch supply going up to the header. And sometimes boilers are larger and they require 2 2-inch supplies, or they might require 1 2.5-inch supply. The manufacturer tells you what you should have, and a lot of people don't look at the manual that comes with every one of these boilers when they install them, because they say, oh, I've been installing boilers for 30 years and nothing bad's ever happened. Now, I can almost believe them after making these videos, because what this video is going to show is you can dramatically undersize a steam supply in a residential, low pressure steam boiler. I gotta make sure I dot all my I's and cross all my T's when I make these videos, because everyone calls me out on weird things. But in a residential steam boiler, I will say undersizing it, so far I have not seen any evidence that undersizing the steam supply is a problem, okay? And the reason we see the undersizing a lot of times, especially if it's a boiler that calls for 2.5-inch or larger pipes, is because these guys don't have their threading equipment for anything larger than 2 inches, right? I certainly don't, and I didn't need it because I have a small boiler, but also I used pre-cut nipples for all of my 2-inch stuff, right? So we see these boilers that are like, oh, that's supposed to have 2 2-inch tappings, you know, one here 2 inches, one here 2 inches going up to the header, and we see yours only has a single one, and so that's bad, and that's causing your carryover. Because a very common complaint of people who come on heatinghelp.com is they have carryover, right? And carryover, again, to me is when boiler water in great quantities, gallons of boiler water, are thrown up the supplies into the header, possibly all the way up to the main. I've seen it on my old boiler that happened. And when that happens, the gauge glass on the side of the boiler drops down, not just a little, not like this kind of thing, but it goes shoom, all the way down to the bottom. Sometimes the low water cutoff kicks on because it sees there's no water in the boiler. And so people are like, what do I do about this? Because it's kind of it's kind of shocking and weird when you see it happen. And I've been over to people's houses where it was happening. It happens. And we always say, well, show us pictures of the piping. Well, and that's fine. It's good to see the pictures of the piping. And let me make it super clear. Always pipe to the manufacturer's recommendations, okay? At least. You can go over that, you know, if your customers are rich and don't care. And, you know, you can get lots of jobs quoting a lot of money to overpipe a boiler. We've seen that. And that's fine. You know, that boiler is going to operate just great. But I think it's misguided advice to tell these homeowners that you need a bunch of near boiler piping to solve this problem. All right. After doing these videos and based on, you know, all the weird stuff I've done with my boiler, the carryover happens, as I've defined carryover. Okay, there's some different definitions out there potentially, but mine is the traumatic one. There's carryover, I say, happens because of poor water quality, which is oil in the water. We know that causes it because I've done it on this boiler. I have videos. You can look in my video list and you'll see, you know, what happens when you add oil to your boiler. Well, it causes carryover. Once I did an experiment where I tested out Surgex in my boiler, and that seemed to cause carryover. Now, I don't know for sure it was the Surgex. It might have been interacting with, I don't know, something else in my water, but my water was clean at the time when I put the Surgex in. It wasn't surging, if I remember correctly. Anyway, the surging went nuts when I put Surgex in, okay? So there's different stuff that can happen. Oh, and I think if you have a lot of mud in your water, sometimes I think that can cause surging. I've seen people's houses where, you know, it wasn't like a new boiler install where there'd be oil in the water. Something caused it to carry over, you know, or surge. So that's the point of these videos, all right? The point of these videos is not, hey, everybody should make smaller steam supplies. I have never said that. The point of the video is not, hey, every single time you have carryover, it's due to this reason or that reason. I'm just saying, from what I'm seeing, you can't cause carryover. I have not been able to cause carryover yet by undersizing this supply. So let me go back to where I was with the last video. The last video I used these size sight glasses. They're like 1.25 inches inside diameter. So these 1.25 inch sight glasses, I had one here and I had one here. Now they were up a little higher because I had a valve here and I had a nipple here. So they were up a little higher, all right? I lowered these purposely, which I'll probably get a chance to talk about. Let me put this sight glass away. So the old one, it had like 1.5 inches down here, and then it had the two sight glasses at 1.25 inches, and then up here, this wasn't here, but it plugged directly in up here to this 1.25 inch corrugated pipe, connector pipe that's up there. And that formed, you know, the riser, the steam supply riser up to, you know, basically up to the drop header, up to the header. And you can watch the video. I'll try to link to it. It showed the boiler worked fine, right? So I went from, and I do that, and I test that by turning off my other supply. So this is still piped at 2 inches here, but I have this ball valve, so I have this off. So all the steam comes through this side. So in the old video, 1.25 inches did great. You could see some condensate sort of collecting here, but it was just the condensate from the pipe and from the glass that was making its way down here, and then that's kind of where the steam sort of held it. The velocity of the steam, which is faster in a smaller piping scenario, right, was holding the water here. But there was nothing dramatic. There's no carryover. I can't, for the life of me, picture again, in a residential boiler that's at normal residential pressures and flow rates, what would cause water to get, quote, sucked up into the supply. All right. So then, someone on the Heating Help Forum with the username 1095, he's pretty cool. He wasn't really impressed with my videos. He's like, well, why don't you run 1/2 inch, piping? Well, that's a big step down from 2 inches to 1/2 inch. But I thought to myself, someone's going to question this, go smaller. So even before I got that message from him, I had already purchased and I'd already ordered these 1 inch sight glasses. So these are smaller. These are 1 inch, and this is one of the fittings, one of the 1 inch fittings. I think it's a hair larger than 1 inch, okay? But it's a nominal 1 inch for these sight glasses. It's all I can do. I can't specify the exact inside dimension. I can only order them, right? So they call these 1 inch. And the glass, inside the glass is pretty much 1 inch. So, it was also suggested to me by a couple of people, hey, get rid of all this junk on the bottom and run the sight glass way down here close to the boiler so we can see if anything is getting pulled up into it, right? Now, even if it was getting pulled up into it, it wasn't going anywhere because we never saw it appear in the sight glass. So I don't consider that any kind of serious carryover by any means, right? It's just some water splashing up if it's there. But now this is much, much lower, several inches lower. I think before they were like around this, oops, you can't see my finger. They were around this high before the glasses even started. So now I'm a good, 4 or 5 inches lower. So I've got inside here, you can't really see it, but there's a 3 inch to 2 inch bushing because these ports are 3 inches. Then there's this stainless steel 2 inch to 1 inch bushing inside that. You can see that. And then that's a 1 inch fitting on the bottom of the sight glass going into the 1 inch glass, going into 1 inch another glass, going up here because of pardon my zoom. Because of I didn't have every fitting in the world here in my basement, I had to go 1.25 inches here. And then this is 1.25 inches to 1 inch adapter. So I'm taking it back to, this is a 1 inch steel pipe. It's like, 6 inches, 5-6 inches long. And then it goes up here, back up to 1.25 inches. And that's the size of my connector tube up there is 1.25 inches. So we are sitting at a couple feet of 1 inch supply piping. And we're going to see what this boiler does. Now, as people also pointed out, this is the smallest boiler that Peerless makes. It's, if I recall correctly, it's 233 net square feet of steam. So that's how much it supplies. That's how much steam it makes. And what can I tell you? That's the size of the boiler in my house. So it's not the smallest boiler that's commonly available. I think either Wild McLean or Utica has a smaller boiler available, but this is the smallest Peerless. What else can I tell you? I can tell you the water line is about here. I'm running the water line. Let's see if I show you, it'll mess up my camera, but I'll show you. You want to see this. The water line, I got to get down here. Sorry, I got to bend down. Is higher than called for by the manufacturer by, between 1 and 2 inches. All right. So I'm running a higher water line. Number one, because I like to, for other reasons that I've talked about in the past. But the other reason I'm running it higher is because I kind of want to hope to see if something happens here, or to use it as evidence that, hey, look, even with the higher water line, am I going to see any carryover start here, right? And in my video 2 videos ago where I talked about my boiler got contaminated, where it was doing a little bit of surging, we saw that boiler water was coming up about this high in the 2 inch glasses, in the 2 inch piped supply. but it wasn't going up. It didn't seem to be going up across into the drop header. So, all right. Once again, I'm talking way too long, and I think my my low water cutoff, my cycle guard just turned off. So I'm going to go over here and turn on the call for heat, and the damper has opened, and so now we're going to see how this goes down. This piping has cooled a little bit, right? So once the steam starts to flow, we should see some condensate run down here. I'm going to zoom in because this is the interesting part. We should see, and I put some pieces of paper behind here so we can see it a little better. Trying to get the production values up a little bit in this place, right? So once the steam starts to flow, we'll see pretty quickly, we'll see some condensate start to form here, and we'll see what happens. Again, this other supply is totally turned off, right? And I also got smart and I put I turned my pressure gauge around so we can see it from the camera, like it will be very helpful. And we'll see if it goes above the normal operating pressure, which for my boiler at a typical time, it might be 1 inch, it might be a half an inch, it might be 2 inches, and then that pressure would go up as the longer the call for heat was. So we're gonna see what happens. Oh, here we go, we're starting. So now see this? This is condensate, because my boiler water is purple, right? Because I got 8-way in it. This is condensate that formed in these pipes, you know, from all this cold pipe up here created that water when the steam gave up its heat to heat those pipes. But now already the pipes are pretty clear of condensate. Now one thing that's different for these 1-inch pipes compared to my last video is, and now I'm going to zoom in so we can see this. You can see the steam velocity, which is quite faster now than it was in the last video, and definitely way faster than it is when it's just a 2-inch pipe. The steam velocity is such that it is carrying with it on the sides of the pipe right now, okay? Not entrained in the steam, but the condensate that's forming here on the pipe, and it's forming, you know, all below this area, all of this is forming condensate from the heat that it's giving off. All this is like a radiator. The steam is blowing or carrying the condensate upward. And again, it's on the sides of the glass, all right? I want to make that point pretty clear. This is not droplets of steam. Excuse me. This is not droplets of liquid water entrained in the steam. I have never, in all the crazy stuff I've done with my boiler, with all these sight glasses, I have never once seen the phenomenon of droplets of water being carried in with the steam. Again, I got to be so careful with what I say. They might bump up here. If I got rough boiling, they might show up. But what happens is they hit the interior wall of the pipe, and then they normally run down. Right now they're running up because the steam is so fast. And again, I'm not counting full-on carryover where the boiler water is so oily and messed up that it's just chucking gallons of water up the supply, which again is a thing that happens. I've got videos showing it. Everyone who's been out there in the field knows there's times when a boiler carries over, all right? So this is cool because in the other video, when it was 1.25 inches, the steam was not moving fast enough to carry up the condensate up along the walls of the pipe. It was right at stasis. It was sitting right here jiggling. Just like when water is getting blown up on your side window on your car and it sits there at that level and it jiggles, and if you slow down then it runs down because the wind is no longer holding it up there. That's what's going on in here. And if we look up here at the downhill side of the drop header, we can see the condensate is getting carried down along the sides of the pipe. It's not in the steam, okay? It's collecting, it's just running down the sides of the pipe, just like all water in the real world runs down the sides of pipe. It doesn't really, travel floating in air, especially after a period of time, right? Eventually it's going to hit the wall and stick to the wall, and then it's just going to run down the wall of the pipe. That's what we see in here. And then if we go up here, let's see if I get my where am I? I'm lost. Oh, way up there. I'm going to lift this, okay? Sorry about this. This is the glass that shows the steam going above my drop header into my main. Here, I never see anything splashing unless my boiler is carrying over a lot. When it's really carrying over a lot, sometimes I'll see some, sorry, excuse my finger, but I'm illustrating. I'll see some splashing right here. I have never driven this boiler with such ridiculous water quality that it actually went up into the main since I've installed this boiler. Because I do have a good header with a good header drain pipe that runs down, right? All right. So that was kind of cool. Here I am. Sorry about that. Not the greatest cameraman. So let me show this a little bit. We'll watch it for a second. I think it's pretty cool. It's the condensate going up the pipe. Again, when it was this is an inch pipe. When it was an 1.25 inch pipe, the velocity of the steam wasn't there. So so let me ask you all, looking at this. Here is a Peerless 6303L piped with a 1 inch supply. Can we maybe think about how we shouldn't advise homeowners to go repiping their boiler just because they have carryover? Is that possible, that maybe we tell them that too much? I've certainly told people that. I'm like, oh yeah, number one, you don't have a header. Number two, your supply pipe is too small. I don't even need a header. All right, I got this double drop header here. I don't need it, because even here, if you imagine this pipe making a turn here, going straight into the header, you'd have almost no water going into that header. You'd only have the condensate from the pipes themselves. And if these were insulated, there'd be even less water here, okay? I don't believe any of this water comes from the boiler water. It comes off of the steam. And as I said in the last video, when the steam is streaming past here, it again, I don't know the right word, it re-evaporates some of this condensate back into steam, which then, gets carried off into the system to heat your house. So here it is. It's my boiler being driven with 1 inch supply pipe, no carryover, no condensate problems, no knocking, no banging, no nothing. Pretty cool. I mean, I think it's pretty cool. I don't know what to tell you. Now let's look at the pressure. This is higher than my boiler runs when it's got 2 inch pipe. All right, no question about it. This is a constrained, a constricted supply situation, so the pressure in the boiler is higher, and it's bopping around at about 8 inches of water column. And I'm normally, like I said, down at 1 to 2 max. So I'm gonna do something here, and we're gonna watch what happens, see if anything interesting happens here. Let me get zoomed in so it's a good picture for everybody. Again, sorry about the bumping and stuff. All right, so here's the valve that opens up my other supply. I'm gonna open up the other supply to allow steam to go through here. Now, it's my feeling that when this one is open, the steam flowing over here is going to go down probably close to nothing, or maybe nothing, because this is just going to be so much easier for the steam to go through this 2-inch pipe. So let's watch what happens. I'm going to do it slowly. All right, we see some condensate that had collected on the valve gets pitched up into here and just kind of bounces around a little bit. The reason why it's bouncing around a little bit is because I got the valve half open. So this is also constricted, right? But once I go full open, we're going to see that 2-inch glass is showing no activity at all. And I can tell you from experience that when this is the case, any condensate is now running down back into the boiler. Because with the 2-inch supply on this boiler, the velocity is slow enough that that's what happens. And the manufacturers, they like that. They don't want the water to get carried up into the header. They would like that not to happen. They have you pipe, a so-called equalizer header drain to let the header drain the water out in case you do get some. And I think that they do make these very conservatively designed so that if you do find carryover occurring, it's not a nightmare scenario. But we have seen the nightmare scenario, and that's what I call it, when the water does actually get pitched all the way up into the main and empties your boiler out, because gallons of water are now rushing through your system. I saw it right here in my basement with my old boiler, and I know other people have seen it. So there you go. I think that's the end of this video. 1-inch supply pipe works. I'll close this back down and let you look. I'm going to close it and let you look at this supply pipe again over here. I'm closing the 2-inch side. There it goes. A little bit of condensate is now visible. It's getting pitched upward, up toward the drop header. It's going to go up and around, and it comes back down here into the header, and it just goes down the header drain. Okay? So I know I won't be telling anyone to pay someone to repipe their boiler if they're running like a 2-inch pipe instead of a 2.5, or if they're running a single 2-inch pipe instead of supposed to be 2. We know those boilers, we've known those boilers can work, and this shows that a boiler can definitely work with a greatly constricted supply pipe. And I'll do the math. I should have looked this up before my video, but I'll do the math and I'll put up on the screen how much percentage smaller this cross section is of a 1-inch pipe compared to a 2-inch pipe. It's not half. It's way less than half. So I'll put the math up on the screen for everybody to look at. That's it. Oh God, 28 minutes. I am so sorry, but I'm trying to say everything correctly and it takes a lot of words. So take it easy.